Hi everyone. So today I'm going to share with you the story of currents. So current is defined as the rates of flow of charges, and this is a definition that you need to memorize. Equation for current is this: I equals to Q over T, where Q stands for charge and T stands for time. So the units for current is written as A, which stands for amperes, and it can be written as coulomb per second. If you can see the units over here, you figure out why amperes means coulomb per second. So what exactly does current mean? You should know that an EMF of a battery provides the motivation for charges to flow in a circuit. So this current or these charges can flow very quickly, can flow very slowly depending on the resistance that the charges face along the journey. So this is how we figure out a current in a circuit. You look at one particular point. Say I choose this point to look at. Alright, and I will count how many coulombs worth of charges go past this point every 1 second. And if I can literally count the number of charges and the amount of coulombs of charges that pass through this point in 1 second, I will get amperes reading, and that is the meaning of current. The amount of charge that pass through one particular fixed point in a circuit every second. Okay, so say this battery provides the circuit motivation for the charges to move, and say the current here is 2 amperes. Alright, so this means that with every 1 second that passes, 2 coulombs worth of charges flow past this point. Alright, and if I choose this point to analyze, and let's just take the direction of conventional current, which is something that I will look to later on. At this point, we are also going to get the same 2 ampere of current. Why so? The analogy of current is similar to water flowing in a pipe. In this pipe, if at the start there's 2 units of water that's flowing, everywhere along the same pipe, you are going to get the same amount of water that's flowing. 2 units flowing here, 2 units flowing here, 2 units flowing here, 2 units flowing here, and same thing here, 2 units flowing here. The amounts of current, be it electrical current or water, volume of water, cannot diminish along the same pipe, because if there is any change in current here, it implies that some charges or some water has been lost along the journey, which is nonsensical. So the current that flows through a series circuit is the same throughout this series circuit. 2 amperes at the start and 2 amperes everywhere around the circuit. Now, the last part of a current is about the direction of current flow in a typical circuit. We always take conventional current to be the flow of positive charges around a circuit. And you can see it in the direction of the arrows that are drawn. It's as if protons are the ones that are moving along the circuit. Alright, this is what people come up with in the past before they discover electrons. So it took scientists a while before they realized that, hey, protons can't really move around a circuit. What actually moves around the circuit will be the free moving electrons. So conventional current direction is therefore opposite to the direction of electrons flow. Now, even up to today, when physicists is analyzing electrical circuits, we still use the direction of conventional current, because this idea has been stuck with us for a pretty long time, and we decide that it's easier to use the direction of current as if it is the photons that is moving. So in all examples that you see, just take note that the direction of current is usually taken to be conventional current. And if you need to figure out the direction of how electrons are flowing, just swap the direction. And that's it for the story of current.